straight line, we studied kinematics. What was kinematics? What was kinematics? It is the study of motion without considering the cause of motion. What is the cause of motion? What is the cause of motion? This is at rest. Now it is momentarily in motion. What is the cause of motion? Force. Right? Applying a force is the cause of motion. So, in kinematics, we studied motion without considering the cause of it. Here, we are going to study kinetics or dynamics. What is kinetics or dynamics? What is that? That is the study of motion. It is study of motion itself by considering the causes of motion. By considering the causes of motion. So, we are going to study the part of kinetics. Okay? Do you know what are the forces in nature? Do you know what are the forces in nature? This is just an introduction. You don't have to study this. This will not come in the exam. Forces of nature, forces that exist in universe. Do you have any idea of that? There is a total of 4 forces in the universe. Only 4 forces. Every force you can see will be among any of these. Right? There is only 4 forces in the universe. The first force you are familiar with. You are familiar with the first force, that's gravitational force. Gravitational force. Gravitational force. First force is gravitational force. You are familiar with the gravitational force, right? Gravitational force. What is that? What is that? What is your idea of gravitation? Your idea of gravitational force. What is that?
Force depending on gravity.
Or only Earth can have this pull? No. If there is another planet that can have that pull also. If there is moon, if you are going into moon, is there gravity in moon? Is there gravitational force in moon? Yeah, there is gravitational force in moon. And moon can influence the heavy mass water bodies here also. Heavy water bodies here also. Moon can influence that twice in a month. Right? And so moon has a gravitational force. And we of course know sun has a gravitational force. Because of the gravitational force of sun, Earth and all the other planets, revolve around the sun. Right? So there is a pulling force towards every planet or every stars, or we can simply say every masses. Every masses. As the mass increases, that pulling force will be increasing. As the mass increases, that pulling force will be increasing. That will be your idea of gravitational force. But as we study furthermore, you will understand the gravitational force is nothing like the other forces. This actually, let me say this to you. I'm happy that I am the one that is breaking this idea to you. Gravitational force is actually a curvature in space-time. Have you heard about this term space-time? Space-time. What is space-time? No, this is not a time and space. This is a single word. Space-time. Up to Einstein, the space and time were separate. When Einstein came and put forward the theory of relativity, then there came a new word that is space-time. Space-time means if there is a mass, that mass can bend space-time. That mass can bend space-time. If there is a mass like this, imagine this is sun. Sun has a huge mass. Huh? No, you don't have to. You don't have to study this. You will not study this in higher secondary level. Maybe when you are going to degree level, graduate level physics, you may study the equations along with it also. If you have a huge mass, that huge mass can bend the space-time around it. Bend the space-time around it like this. I cannot draw that. Yeah, black hole, and every stars, every planets, everything. Gravity works like this. This is a bend. This is a bend of space-time. Not only space bends, but time also bends. What is that? Time also bends. When you are studying this further, you will understand that time also is relative. Time is relative. You will understand that. Time travel, everything is, now it is science fiction, but maybe in a future time that will become science. I don't know. We don't know. And this is the space-time curvature. Gravitational force is actually space-time curvature. This is just an introduction to the actual nature of gravitational force. If you are interested, you can read further. Okay. And what happens to the Earth? This is, if this is sun, and if this is Earth, what will happen to Earth? Earth will be coming towards the sun. Will be coming towards the sun, and every objects in the universe, in the space, is in uniform motion. In motion, it is in motion. So if it is coming here, and there is some forces acting there, don't have to study that. There is some forces acting there. And due to that effect of all the forces, the resultant forces, the motion will be circular. It is not actually circular. Earth is not actually just in circular motion. It is actually circular motion and translatory motion. Earth is revolving around the sun and it is moving forward also. It is moving forward also in the through the space. Sun is not just revolving around itself. It's just not rotating around itself. It is rotating, and also sun is revolving the center of the galaxy also. It is revolving the center of galaxy also. So Earth is itself rotating. It is revolving around the sun. They together revolve around the galaxy, and they are moving in a direction. They are moving. Everything is moving. Everything is expanding. That's the case of astrophysics. There's a branch in physics that is called astrophysics. You will not study that here. Maybe in 9th standard, you have studied a little bit of that. In 9th standard. That will be the end of the astrophysics that you have studied. And you have to study gravitation here. There is a chapter called gravitation, and we have to study gravitation. That's mostly contains everything that is related to Earth's gravitation, and maximum they will discuss about the satellite. That will be all. Okay. If you are interested in astrophysics, you can read that further. That's very interesting to know. One, when I first encountered with this idea, that just blew my mind. That what is gravitation? We just studied in school. What is gravitation? Gravitation is the force with which the Earth or any planet attracts every object towards its center. That's the simple idea of gravitation. We all know that, right? But when I encountered this idea, gravitational force is actually the curvature in space-time. That actually was a very eye-opening idea for me. If you are interested, you can read further. Okay. Okay. So that's gravitational force. And you have to understand something. This gravitational force is the weakest force among this. It is the weakest force. You know the size of Earth, right? Earth is very huge, and Earth attracts this object. If the object is sitting on the ground like this, Earth attracts this object. But I can cover that attractional force. I can overcome that attractional force because I just can pull it up. I can just pull it up. Earth is attracting it, but I can pull it up. Right? So the gravitational force is actually a weak force, weakest force. Okay? So that's gravitational force. Then there is a force called weak force. Weak force. Weak force. You don't have to study about this weak force. Weak force is actually coming when the particles are decaying. And protons become some other particle due to decay. This is the force that comes there. You don't have to study weak force. And there is another force called nuclear strong force. This is also a nuclear force, a nuclear weak force, nuclear strong force. Strong force, strong force. It is called nuclear strong force. Nuclear strong force. I will make you understand that is pretty simple. What is the tiniest part of an atom? What is the tiniest part of an atom? Indivisible part of an atom. Atom has its nucleus, and nucleus is made of protons and neutrons, right? There is electron, and this proton is divisible. Is proton divisible? Yes, proton is divisible, and quarks are the single tiny materials that is combining together to form these protons and neutrons. Quarks. Okay, so strong force is the force which hold together these quarks. Quarks are combining to form protons and neutrons. And a strong force, nuclear strong force is the force that is holding them together, binding them together. That is called the strong force. And there is one force called the EM force. Can you guess what is this EM force? Electromagnetic force. Electromagnetic force. Electromagnetic force. Okay, I will exhibit a force here. I will apply a force here, and you can tell me which force is that. Okay, what is this force? Which element is this force? Is it gravitational force? No. Weak force? No, it is inside the atom. Strong force? Inside the nucleus. Electromagnetic force? Yes. Every force we are seeing is actually electromagnetic force. Because the particles are the one interacting here. When I am touching something, there is actually interaction of particles. Okay, we will experience that in any other forms, but every force that we will be encountering will be electromagnetic force in nature. When we are going inside of it, when we are taking a microscope and going inside of it, that's actually the attraction between two particles. It's actually an attraction between two particles. That's very interesting to study. If you get time, you can do that. In 11th standard, you will get enough time to read. When you are in 12th, you will not get any time to read extra. So you can read if you are interested in any of these during the 11th grade. Okay. Okay, so this is the introduction to forces. Many forces are there. These are the fundamental forces in the nature. These are the fundamental forces in the nature. Did you understand that? And in simple way, we can define force like this. What is force actually? In general way, when we are considering mechanics, if we are talking about mechanics, what is force actually? Force is an external effect. What is that? An external effect in the form of push or pull. It is an external effect in the form of push or pull. That is actually force, right? We will study more about force in the coming part of the chapter. Push or pull. An external effect which is in the form of push or pull. What can force do? What can force do? What are the effective forces? Yes, it can move an object which is at rest, or it can stop an object which is in motion, or it can change the direction of any object that is going in a particular direction. These are the effects of forces. Okay, so we are going to study about the force here. Okay, and I want to take your minds to, or I want you to recall some little things that we have studied in the past. Do you remember internal forces and external forces? We have studied that in the lower classes. Internal forces and external forces. Internal forces and external forces. Remember that internal forces. Internal forces are the forces that exist between two particles in a system. In a system. If you are considering this classroom as a system, we will be the particles in that classroom. I am a particle, you are a particle, you are a particle, you are another particle. If we are considering this classroom as a system, we will be the particles. If there is attractional force or push-pull force between us, that can be considered as internal force. Right? That can be considered as internal force. So internal force are the, what is internal force? Internal force is the force of interaction. That can be attractive, that can be repulsive, anything goes. Force of interaction between particles inside a system, that's internal force. Is that okay? Okay. Then what is external force? External force. Force that comes from outside of the system. Force that acts on a system. If you have a system here, and a force is acting on the system, then that is what? That is an external force. You have to understand a very fundamental thing. Internal force cannot move an object. Internal force cannot move an object, but external force can move an object. Only the external force can move an object. No internal force can move an object. Right? Okay. So that's the first thing. And in the textbook, there is a thing called, there is a small idea called Aristotle's fallacy. Aristotle's fallacy. Aristotle's fallacy. Do you have you heard about Aristotle? He was a Greek inventor and thinker. Okay, Aristotle. And Aristotle thought, this is we are talking about the history of history. Aristotle thought every object which is in motion definitely needs a force. Aristotle thought every object in motion needs an external force. That was the idea of Aristotle. Right? Okay. Then there came Galileo. There came Galileo. When Galileo came, and Galileo Galileo did some experiments and reached into some other ideas, which was different than Aristotle's ideas. Galileo did his experiments and understood that every object in motion does not need an external force. There is so many experiments of Galileo. One was like this: if there is a ball like this, and if you have taken, have you studied this in time? If there is something like this, something like a basket like this, yeah. Then if you are releasing a ball like this, that ball will go up like this. The ball will reach exactly the same height, right? The ball will reach up to the same height, Ball will reach up to the same height. Okay, and if you are making it slant, making one side of the basket more inclined, what happens? The ball has to travel more to reach the same height. Ball has to travel more to reach the same height. Okay, and what happens if you are increasing that further and further and make it horizontal? Yeah, when we release the ball, it will go on moving. It will not stop its movement. The ball will go on moving. The ball will have something called inertia. The ball will go on in that direction. It eventually stops. Right? why do the ball stops? If I have a ball here and I am rolling that ball through this ground and it will go on for some time, yeah, it will stop eventually. It is because of friction, not because my force hasn't spent out, not because my force has spent out, right? It is because of the friction. Because of the friction, the ball moves for some distance and the ball stops because of the friction. If there is no friction, what happens? If there is no friction, the ball will go on. It will go on. It will move on. It will not stop anywhere. If there is friction, the ball will stop. If there is no friction, ball cannot stop. This was the ideas of Galileo. Okay. After the time of Galileo came someone called Isaac Newton, and he is our celebrity. He is our celebrity in the world of physics. Isaac Newton is our celebrity, our legend. Without Isaac Newton, all this you are experiencing here and you can feel here will not be a reality for maybe 100, 200, 300 years. For that much years, that will not be a reality. Newton studied every then branches of the physics, that then existing branches of the physics, and gave his own ideas, his own theories, equations to the physics, and to mathematics also. When Newton was trying to do some calculations, he understood that then existing mathematical tools are not enough to do that calculation. So what did Newton do? He invented a new branch of mathematics that is called calculus. You may have studied calculus if you have taken maths by now. Calculus, differentiation and integration. This is really very crucial. You haven't studied that.
The last of the book.
Yeah. You will study if you have taken maths. Yeah. In the 12th maybe, you will be studying calculus, differentiation and integration. We know that it is very crucial to us. In the second chapter itself, when we were discussing the second chapter itself, we understood that we need calculus to do such calculation. We need such calculation, and time it is not constant. It is changing. Some quantities are changing with the time, so we need calculus. At that time, when Newton was doing that calculations, he understood that the calculation then existing will not be enough to do this calculation, finding this calculation. So invented a new branch of mathematics. Okay. So then came Newton, Sir Isaac Newton. And there is three laws of motion which is put forward by Newton. They are called the laws of motion. Newton's laws of motion. No, just there is only one equation. If you consider the third equation as an equation, then there will be only two equations. For first Newton first law, there is no equation. First law is actually an expansion of Galileo's ideas. First law of Newton is actually the expansion of Galileo's ideas. Galileo thought about this idea, and Galileo named it as law of inertia. What is that? Every object has inertia. That is law of inertia. And an external force is not needed to continue the motion. That's an idea of Galileo, and the name of that law was law of inertia. Newton modified the law of inertia and put forward his first law. That is Newton's first law. We will be discussing Newton's first law here. What What is it? Newton's first law. If I take this glass, you can see this glass, right? I am taking this glass and I am placing this glass on my hand. How much time this glass will be here? How much time will the glass be here? Forever. It will be here forever. If I haven't applied any force on it, the glass will be here forever. It cannot move by itself. It cannot move by itself, right? Okay. And if there is a ball, rolling on the ground, when it can stop? When will be that ball stopping? When will be that ball stopping? When that ball can stop? When there is a force acting on it, then only that ball can stop. Otherwise, the ball will not stop. It will go on. It will continue its motion. It cannot stop by itself. This is Newton's first law. These two statements are Newton's first law. Any body cannot move by itself, right? Cannot move by itself. If there is a moving body, cannot stop itself. If there is a moving body along a straight line which is in a uniform motion, that moving body cannot stop its motion unless an external force comes there and is acted upon that. Unless an external force is in the scene and that external force is compelling that object to stop motion or increase its velocity, something like that. So that's Newton's first law. What is Newton's first law? Every object in the universe continues in its state of rest. That is the state of a body. State of rest. State of rest or of uniform motion along a straight line. What is uniform motion? Uniform motion along a straight line. What is uniform motion? Do you remember this term? Uniform motion. Uniform motion. If the object covers equal distance in equal interval of time, or the object has equal displacement in equal intervals of time, that type of motion is called a uniform motion, right? So if an object, every object which continues in a state of rest or of uniform motion along a straight line, unless compelled by an external force, only if there is an external force acting upon that object, then only that object can move, or if that object is a moving object, it can stop. Otherwise, it will continue to be in its state. It will continue to be in its state. What are the states of an object? There is two possibilities for state of an object. What is that? State of rest or state of motion. I am at a state of rest. I am now in my state of rest. If I am moving, this is my state of motion. Right? So there is only two states for a body, for any body. One is state of rest, or the other one is state of motion. You got it? So what is Newton's first law? Newton's first law states that every object continues in its state of rest or of uniform motion along a straight line unless compelled by an external force. Any internal force cannot change the state of a body. Right? Internal forces cannot change the state of a body. Only the external force can change the state of a body. Got it? This is Newton's first law. Can you give me any examples for Newton's first law? Any examples? Any examples? Imagine a space shuttle. Imagine a space shuttle in the space. There is no air in the space, right? No air in the space, so there is no air friction. If every rockets are turned off, what happens to that space shuttle? That space shuttle will move. It will move. It will continue to move. It will not stop anywhere. It will not stop anywhere unless it hit on any object, or unless its engines or opposite force, we are giving any opposite force to stop or slow down that. Unless we are doing that, until we are doing that, the space shuttle will be moving on. It will be continuing its motion. That can be an example for Newton's laws. You got it? Okay. And anything at a rest, any object at a rest is an example for Newton's first law. Any object at a rest is an example for Newton's first law. What happens if an object is in rest? It will continue to be in rest. That's actually an idea of Newton's first law. So any object which is in rest is an example for Newton's first law. Got it? We can write that. You can write that. First, we need to write internal forces and external forces just like this. Internal forces and external forces like this. You can write that in a column. Internal forces and external forces. You just need to write what is internal forces and external forces. Right below internal forces, right below internal forces, forces which do not change. Forces which do not change mechanical energy of a body. Mechanical energy of a body. It's a fancy way to say the object cannot move using internal forces. Did you understand that? Huh? If an object is moving, its mechanical energy changes. If an object is moving, its mechanical energy can change. If there is forces inside of that object or inside of that system, and the mechanical energy of the system is not changing, then that force will be internal force. You got it? So this is a fancy way to say the force inside of the body. Okay? Okay. Right. Force exchanged by the objects in the system. Below that. Force exchanged by the objects. Force exchanged by the objects in the system. Force exchanged by the objects in the system. In the system. Got it? Then you can write external forces. External forces. External forces. Force applied to the object. Force applied to the object. Force applied to the object. Force applied to the object from outside of the system. 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 It can change the state of a body. It can change the state of a body. It can change the state of a body or direction of the body. Or direction of the body. It can change the state of a body or direction of the body. Got it? It can change the state of a body or direction of the body. Okay? Then you can just write Aristotle's fallacy. Fallacy means mistake. Fallacy means mistake. Why do we study mistakes? Why? What is the use of studying mistakes? Why do we need to study mistakes? Yeah, because we should not do the same mistake again. We should not think of the same mistake again. That's why we are studying, we are understanding mistakes. So, Aristotle's fallacy or Aristotle's mistake, Aristotle's fallacy. Just you can write it in a simple sentence. An external force is required to keep. An external force is required to keep. An external force is required to keep a body in motion. A body in motion. That's wrong, right? That's wrong. That's a fallacy. That's a mistake. Fallacy means mistake. That's a mistake. Okay, then you can write the law of inertia by Galileo. 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 Okay, you can simplify that like this. No. Do you need Aristotle's fallacy, Shiga?
Yes, sir.
Yeah, an external force is required to keep a body in motion. An external force is required to keep a body in motion. Aristotle thought like that. An external force is required to keep a body in motion.
Okay, thank you, sir.
Okay. Then law of inertia by Galileo. Law of inertia by Galileo. Okay, you can write. If net external force is 0, if net external force is 0, if net external force is 0, body at rest continues in rest. Body at rest continues to remain at rest. Body at rest continue to remain at rest. Body at rest continues to remain at rest. Continues to remain at rest. Body in motion continues with the uniform velocity. 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 Got it? Okay. Then we can write Newton's first law. You can write Newton's first law. Write Newton's first law. Newton's first law. Newton's first law. Write Newton's first law. We are going to state Newton's first law now. Okay? Newton's first law. You can write it. Every object continues in its state of rest. Every object continues in its state of rest. State of rest. Or of uniform motion. Or of uniform motion along a straight line. Or of uniform motion along a straight line. Or of uniform motion along a straight line, unless compelled by an external force. Unless compelled by an external force. You don't have to study an equation from this statement. There is no equation in the first law. Okay? This is Newton's first law. And what is Newton's first law giving us? What is Newton's first law giving us? It gives us two ideas. Newton's first law defines force. Newton's first law defines force. And it also helps us to understand inertia. It defines force and it helps us to understand the concept of inertia. Okay? So what will be force? Just read the Newton's first law statement again. Statement again and tell me what is force. Read Newton's first law again and tell me what is force. Read Newton's first law again and tell me what is force. What is Newton's first law? Every object continues in its state of rest or of uniform motion unless compelled by an external force. So what is force? Force is that which changes the state of a body. Right? You can define force with that statement. Force is that which changes the state of a body. Right? Right? Okay? But it's not complete. It's not complete. There is a desk here. That desk is in state of rest. And I am applying a force here. I can move this desk. Right? I can apply a force there and move that desk. I have applied a force there. But what if I am applying that force on this object? What if I am applying that force on this object? I am applying a force here, right? Am I applying force here? Yeah, I am applying force here because I have a small pain here. I have a very small pain here because I am applying a force here. Okay, I am applying a force here. But is there any motion? Is there any motion? No, there is no motion. There is no motion. So what is force? What is force? If there is no motion, there is force. Then you have to change that definition a little bit. Then what is force? Force is that which changes or tries to change the state of a body. Force is that which changes or tries to change the state of a body. That is force. Or in a good word, that will be tends to change. Tends to change. Force is that which changes or tends to change the state of a body, the state of rest or of uniform motion of a body. That is force. Did you understand what is force now? You can define force now. You should write. First law defines force as a point. First law defines force as a point. You can write. First law defines force. First law defines force. First law defines force. Right? The next slide. First law helps to understand the concept of inertia. First law helps to understand the concept of inertia. First law helps to understand the concept of inertia. First law helps to understand the concept of inertia. Got it? Okay, then you can define force. Definition of force. You can write force. Underline it. Force. Underline it. Force. What is force? Force is that which you are defining force. Force is that which changes or force is that which changes or tends to change the state of a body. Force is that which changes or tends to change the state of a body. Force is that which changes or tends to change the state of a body. That is force. Okay? Okay. You got force now. We have to go detail into inertia. Before that, we have to write the examples for first. Okay? You can write examples for first. Examples for first law. Examples for first law. Examples for first law. A spaceship in space. A spaceship in space. A spaceship in space with all rockets turned off. A spaceship in space with all rockets turned off. A spaceship in space with all rockets turned off. Right? Then body at rest. Body at rest. Another example. Body at rest. Body at rest. Body at rest. Or in uniform motion. Or in uniform motion. Or in uniform motion along a straight line. Along a straight line. Or uniform motion along a straight line. Body at rest or in uniform motion along a straight line. Got it? We have defined what is force. We have defined what is force. Now we need to define or we need to understand what is inertia. Okay? We need to understand inertia. For inertia also, we need Newton's first law. Read Newton's first law again, and you will understand what is inertia. Read Newton's first law again. What is first law? Every object continues in its state of rest or of uniform motion along a straight line unless compelled by an external force. That is Newton's first law. What if there is no external force? What if there is no external force acting on it? What happens to that object? The object at rest will remain at rest. The object which is in motion will continue its motion. That is called inertia. Right? A body cannot change its state of rest by itself. That is inertia. Inertia is actually an inability. An inability. Inability of any body. That's inertia. So what is inertia? Inertia is inability of a body to change its state of rest by itself, or state of motion by itself, or simply the state by itself. Inability of a body to change its state by itself. That is inertia. Okay? Three types of inertia are there. Three types of inertia are there. First one is inertia of rest. Inertia of rest. What do we mean that? Inertia of rest. An object at rest cannot move itself unless compelled by an external force. There is no external force, that object will remain at rest. That's called inertia. Inability of a body to change its state of rest by itself. By itself, the object cannot change its state of rest. That's called the inertia of rest. Can you give me an example for inertia of rest? Inertia of rest. Yeah, when we can take that example. When I am standing in a bus, holding the road above my head, I am standing in a bus. The bus is bus is at rest. It is in the bus stand. The bus is in the bus stand. It is not moving. When the bus suddenly moves forward, what happens to me? I will tend to fall backwards. If the bus suddenly moves forward, I will tend to move backwards. Why is that? When the bus suddenly moves forward, and my legs are attached to the bus, so lower part of my body is moving, but I have an inertia of rest. Due to that inertia of rest, I will try to, or my body will try to remain in rest. That's why I am tending to fall backwards. That's an example for inertia of rest. Got it? Or when you are shaking the branches of a mango tree. If you are shaking the branches of a mango tree, the mango will fall down. Why is that? The mango is attached to that branch, right? It is attached to that branch. So the mango will have an inertia of rest. If I am giving an external force, like in the form of shaking, the mango will try to remain in rest. The mango will try to remain in rest and branch is moving. Branch is moving, mango will try to remain at rest. So mango will fall. Okay, it will be detached from the branch and it will fall down. Right? And another one is the do you know how to clean a carpet? Yeah. Do you know how to clean a carpet? We will be cleaning a carpet just like we have some grudges towards that. We will take it and we will beat it. We will take that carpet and we will beat the carpet with something. What happens then? If we beat the carpet, what happens then? Yeah, we are hitting it. So what happens to the carpet? Carpet will move backwards. And the dusty particles has the inertia of rest. So the dust particles will try to remain at rest. If we are hitting the carpet and carpet moves back, the dust particles will try to remain at rest. So the dust particles will be falling down. The carpet only will be moving back. Did you understand all the examples that we have discussed here? So that's inertia of rest. Then there is the second one, inertia of motion. Inertia of motion. What will be inertia of motion? Inertia of motion. The inability of a body to change its state of motion by itself. No body can change its state of motion by itself. If there is a body which is moving along a straight path, along a straight line path, right? Its direction or its motion cannot change by itself. It cannot change its motion by itself. It cannot stop by itself. If a football is moving, a soccer ball, if a soccer ball is moving on the ground, that soccer ball cannot simply stop by itself. There should be an external force, right? There should be an external force in the form of friction or any external force that we can give them. Then only that ball can stop. Otherwise, the ball will not stop. You got it? That is inertia of motion. So, inability of a body to change its state of motion by itself. That's inertia of motion. Can you give me an example for that? We can take the previous example in another situation. If you are standing in a bus and the bus is moving, you are standing in a moving bus. When the bus suddenly brakes, when the bus suddenly stops, what happens to us? We will fall forward. We will fall forward. Why is that? We are in a motion. We are in motion. When the bus suddenly stops, the lower part of my body suddenly stops. But my body cannot come to a stop by itself. My body cannot come to a stop by itself. So my body will try to move forward. Because it was its previous motion. My body will try to move forward, fall forward. That's why we are falling forward. Got it? That's why we are falling forward. When the moving bus suddenly stops. When we are trying to get down from a bus that is slowly moving, can we just get down the bus, get down or jump from the bus and suddenly stop like this? We cannot. We cannot. If we try to suddenly stop like this, we will try to fall. Okay? We will fall down. We will fall forward. Why is that? We have this inertia of motion. Due to that inertia of motion, I cannot stop my motion by myself. I cannot do that. I need some distance. I need some distance to make my body to stop. Have you seen athletes run? Have you seen athletes run sprint? When athletes run a sprint or 100 meter, they will be running as fast as they can. When the finishing line reaches, did they abruptly stop? Do they suddenly stop? They cannot suddenly stop there. They cannot suddenly stop on that finish line. If you have any doubt, you can do that experiment home. Just mark a line and from 100 meters, you can run as fast as you can and try to stop on that line. Can you do that? No. If you try to do that, we will fall down. Okay? We cannot do We cannot stop our motion suddenly. We need some more distance to slow down and then stop. This is because of inertia of motion.
How did we walk
Huh?
into that?
Yeah, when we are walking, we are in control. That's very with a very low speed. Walking is with very low speed. We can control. We are controlling the motion now. We are very simply controlling the motion. If we are speeding up, we cannot. As the speed increases, as the velocity increases,
What if we keep the body in backside and back forward?
even if we are doing that, there will be something called momentum. Momentum will be forward. Momentum will be in the direction of force, in the direction of motion. If we are moving forward, the momentum will be moving forward. So that will be very difficult to stop at that line. There will be inertia. If you want to cover inertia, you have to slow down. Or there should be any block. That you can hit on, or somebody, there should be somebody to catch it. Otherwise, we will go on. Right? Then there is third type of inertia called inertia of direction. Inertia of direction. Inertia of direction. What is this inertia of direction? A body cannot change its direction. If a body is moving, it cannot change its direction by itself. That's called inertia of direction. Right? Have you seen hunting videos? Have you seen hunting videos using hounds? How? What is hound? What is hound? Yeah, that's a hunting dog. Hound is a hunting dog. Hunting dog. Many breeds, Greyhound is native to here, maybe Middle East, I think. In my knowledge, Greyhound is native to Middle East, or Afghan hound. Afghan hound is native to Middle East, that central part of Asia, like that. There is some breeds that is used for hunting. If they are used for hunting rabbits can run very fast. Rabbits and hares, something called a hare. There is another species, just like rabbit. They are not rabbit, but it will be looking like rabbit, and it can sprint very fast. It sprint very fast. If a hound is chasing it, it will be very fastly running and quickly change its direction, like in a zigzag motion. Why is that? Antelope also. If a lion or a cheetah is chasing it, it will quickly change its direction. Why is that? Most of the times, the predator that is chasing them will be of greater mass. They cannot simply change their direction that quickly. If the mass increases, inertia increases. That's an idea. What is that? If the mass increases, inertia increases. Mass increases, inertia also increases. Mass increases, inertia increases. Right? For the predators, most of the cases, the mass will be higher, greater. If mass increases, the inertia of direction will be increased. Then they cannot change their direction very quickly. So the prey can run in a zigzag motion, and maybe it can escape from the predator. Okay, that's it. That's our idea. That's our idea of inertia. And this is very important. Mass is directly proportional to inertia. When mass increases, inertia also increases. When mass increases, inertia also increases. Is that okay? Can we write this? Just write this. Inertia. After that, you can take a break. Inertia. Inability of a body to change its state of rest. or uniform motion, or uniform motion, or uniform motion by itself, or uniform motion by itself, by itself. And you can write this one. Mass is directly proportional to inertia. Mass directly proportional to inertia. Put it in a box. Mass directly proportional to inertia. Put it in a box. Mass directly proportional to inertia. And you can write three types of inertia. First one, inertia of rest. Second one, inertia of motion. Third one, inertia of direction. Inertia of rest, inertia of motion, inertia of direction. Okay. You can write inertia of motion. Inertia of rest. You can write inertia of rest. Inertia of rest. What is inertia of rest? Inability of a body. Inability of a body. Inability of a body to change its state of rest. Inability of a body to change its state of rest by itself. Inability of a body to change its state of rest by itself. By itself. We have to write an example. Write an example. Example. Passengers tends to fall backwards. Passengers tends to fall backwards. Passengers tends to fall backwards. Tends to fall backwards when the bus suddenly moves forward. When the bus suddenly moves forward. When the bus suddenly moves forward. That is the first one. First one. Then write second one. Inertia of motion. Inertia of motion. Inertia of motion. Which is that much? Which one is that? Second one, inertia of motion. What is inertia of motion? You can write it yourself, right? Inertia of motion. What is that? Inability of a body to change its state of motion by itself. State of uniform motion by itself. Inability of a body to change its state of uniform motion by itself. Inability of a body to change its state of uniform motion by itself. By itself. That is inertia of motion. Example. Passengers fall forward. Passengers fall forward. Passengers fall forward. When the bus suddenly stops. When the bus suddenly stops. Passengers fall forward. When the bus suddenly stops. When the bus suddenly stops. Third one, inertia of direction. Inertia of direction. Inertia of direction. Inability of a body to change its direction by itself. Inability of a body to change its direction by itself. Right? Okay. I'll give you one good example for that. One good example. If you tie a string on a stone and you are rotating it. If you tie a string on a stone and you are rotating it, this is in this direction, this is in rotational motion. What if the string breaks? What if the string breaks? What will be the direction of the stone from that point? If at this point the string breaks, what will be the direction of the stone? Along the, there is a word for that. Yes, along the tangent. Along the tangent. So the velocity is along the tangent. A stone will be along the tangent. Stone will be moving along the tangent. Why is that? Stone cannot change its direction. It will move along the tangent because its direction is along the tangent. Its direction of velocity is along the tangent. So stone will be moving along the tangent. You can write that example. That example is more good. A stone attached to a string. A stone attached to a string in rotational motion. A stone attached to a string in rotational motion. A stone attached to a string in rotational motion. Move tangentially. Move tangentially. Move tangentially. Move tangentially. If the string breaks. If the string breaks. Move tangentially. If the string breaks. Move tangentially if the string breaks. Okay. And one more point. Inertia is not a physical quantity. Inertia is not a physical quantity. Inertia is not a physical quantity. It is a property of a body. 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 It has no unit, no dimension. Just a property. It has no unit and dimension. It has no unit, no 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 dimension. You got it? It has no unit, no dimension. Okay, we can take a small break. We can take a 10-minute break. After that, we will continue our session. Right? See you in 10 minutes. Guys, Jaden, Sana, Shiga. We have defined force also. Now, I will be discussing the linear moment. It's a quantity. It's a physical quantity, a vector also. Linear momentum. Okay? Linear momentum is represented with the letter P. It's a vector, that's why there is an arrow on top. So linear momentum. Linear momentum is every moving body has this property called momentum. Momentum is a property associated with a moving body. Every moving body will have a property called momentum. Right? This is called a linear momentum. And this is actually a measure of motion. Momentum is actually measure of motion. It is represented with this equation. P is equal to mv. P is equal to mv. It is represented with this equation. P is equal to mv. It is momentum. P is equal to momentum. mv is the product of mass and velocity. So what is momentum? Momentum is the product of mass and velocity. Okay? Property of a moving body. That's momentum. Measure of motion. In other words. This is actually the product of mass and velocity. So momentum is the product of mass and velocity. What will be the unit of momentum? What will be the unit of momentum? What will be the unit of momentum? Now, how can you find the unit of some quantity from the equation? Just write the units, you will get it. Just write the units of the components or terms in the equation, you will get the unit of the quantity. Mass. Mass has a unit, kilogram. Then there is velocity. What is it? What is happening there? Here. Mass has a unit, kilogram. Velocity has a unit, meter per second. So kilogram meter per second is the unit of momentum. Kilogram meter per second is the unit of momentum, and you have to keep in mind it's a vector quantity. Momentum is a vector quantity. It is depending upon mass and velocity of the body. If the mass increases, momentum increases. Velocity increases, momentum increases. Momentum is directly proportional to mass and velocity. If mass is increasing, momentum will be increasing. Velocity is increasing, momentum will also be increasing. Got it? Did you have the idea? Did you understand the idea? Okay, it is like just like this. We can study this with an example. Consider a cycle, a bicycle. A bicycle is coming here, and it is having a particular speed, and it is hitting on. It is hitting on the wall. It is hitting on the wall like this. Okay, and in the next case, in our next case, a lorry or a truck with the same speed is coming and hitting on the wall. A truck with the same speed, yeah, good, same speed hitting on the wall. What happens? Does the impact same? Is the impact same in both the cases? No, the impact is not same in the both cases. The impact will be different. The damage will be different. Why the damage is different here? Both of them are having the same speed, right? Yeah, mass. There is a difference in mass. For a bicycle, the mass is very less as compared to the truck. If the mass is increasing, the momentum will be increasing. The momentum is the one responsible for the damage. Momentum is the one which is responsible for the impact, damage. Did you understand that? That's about momentum. It is about the momentum, right? Then we have understood what is momentum, and I want to show you one change in momentum. Change in momentum. What will be change in momentum? Change in momentum. What will be that? Change in momentum. Consider a body, and that body has a momentum. You can take it as initial momentum. You can take the momentum of that body as initial momentum. If this is a body and that body has a mass m, and the body is moving in a velocity with a velocity u. The body is moving with a velocity u. U is initial velocity. So the momentum now the body has is initial momentum, right? Initial momentum. When a force is acting on that body, the momentum of the body will change. The velocity of the body will change. The velocity changes, momentum will change. If a force is acting on this direction, the momentum will change. The velocity will change. And now the body has the mass m, and its velocity now changes. The velocity I am taking it as v. The velocity I am taking it as v. V is final velocity. So the velocity has changed, momentum has changed. What is its momentum now? What is its momentum before the application of force? Before the application of force, its momentum is mu, right? And after the application of force, its velocity has changed. If its velocity changed, then the momentum also. Then the velocity, then the momentum of the body is mv. So this is initial momentum, and that's final momentum. Initial momentum and final momentum. What will be the change in momentum? Change in momentum, because we need this quantity. Change in momentum. This is very important. Change in momentum. What will be change in momentum? I can take it as delta p. What will be delta p? Final momentum minus initial momentum. That will be delta p. Final momentum minus initial momentum. Final momentum minus initial momentum. That will be delta p, or change in momentum. Okay, then what will be the final momentum? Delta p is equal to final momentum. Final momentum is mv minus initial momentum is mu. So mv minus mu will be the change in momentum. This is the change in momentum, right? Change in momentum. And if this is the change in momentum, what will be the unit of change in momentum? What will be the unit of change in momentum? What will be the unit of change in momentum? Unit of change in momentum. Anyone? If momentum has a unit kilogram meter per second, then the change in momentum also will have the same unit, because change in momentum means another momentum. So it will have the same unit, right? it will have the same unit. Change in momentum will have the same unit, kilogram meter per second. Okay, I will introduce you another term that's called rate of change of moment. Rate of change of momentum. Rate of change of momentum. What is this? Rate of change of momentum. We have discussed this previously in the class. Rate of change of momentum or rate of change of anything. When you will be getting rate of change of a quantity. When you will be getting rate of change of a quantity or rate of a quantity. How you can find the rate of a quantity? Just divide that quantity with the time. You will get rate of that quantity. Divide that quantity with the time. You will get a rate of that quantity. So rate of change of momentum will be what? Rate of change of momentum. This is the rate of change of momentum. mv minus mu is the change of momentum. Divided by delta t time. So that will be rate of change of momentum. Did you understand this quantity? Rate of change of momentum. Because we need this quantity to state Newton's second law. I need this quantity to state second law. So this is rate of change of momentum. Did you understand rate of change of momentum? Change of momentum divided by time. That is rate of change of momentum. Okay. Again, write this like this. Yeah. Delta P by delta T also. Delta P by delta T. Is that delta P by delta T? Rate of change of momentum. What is that? Rate of change of momentum. Do you need to see Newton's second law? I'll show you Newton's second law. Did you understand this one? Huh? Every points that I have written on the board. Did you understand that? Okay. Then I need this one. I need this delta P by delta T. What is this delta P by delta T? Tell me, what is delta P by delta T? Rate of change of momentum. That's rate of change of momentum. You need Newton's second law and you need Newton's second law. Now, Newton's second law. Newton's second law. Newton's second law is very simple. Very simple. This is what? External force. External force. External force is directly proportional to rate of change of momentum. External force is directly proportional to rate of change of momentum. That's Newton's second law. This is to find or to measure force. With the second law, you can measure force. What is second law? Rate of change of momentum of a body is directly proportional to external force. This is it. Rate of change of momentum of a body is directly proportional to external force. And it takes place in the direction of force. And it takes place in the direction of force. It takes place in the direction of force. Look here. There is a force acting here. There is a force acting on the body here. The body is subjected to a change in momentum in a time t. In a time t. Taking a time delta t. Okay. So the object has a rate of change of momentum now. That rate of change of momentum will be directly proportional to this extent. You need to measure this force, right? If you need to measure the force, just look at the body. You don't have to look at the object which is applying force here. I may be the external force here. I am being the external force here and I am applying that external force here. You don't have to look at me. You just have to look at that board, that object which is moving, which is subjected to this rate of change of momentum, or which is subjected to the change in momentum. If you need to measure the force I am applying here, you just measure the mv and mu, and mv minus mu divided by t, you will get force. So what is force? Force is the rate of change of momentum itself. What is force? Force is the rate of change of momentum itself. Or in other words, Newton's second law. What is Newton's second law? Rate of change of momentum of a body is directly proportional to external force. and it takes place in the direction of force. Force is in this direction, right? Force is in this direction. You can see the direction of force here. Force is in that direction. So the rate of change of momentum will also be in that direction. Rate of change of momentum is a quantity. And that quantity has the same direction of force. What is that quantity? This is that quantity. Delta P by delta T, rate of change of momentum. Rate of change of momentum is a quantity and that quantity is acting in the direction of force. This is Newton's second. This is Newton's second law. Let's try to derive an equation for force. What is the speciality of Newton's second law? Newton's second law will give you an equation for force. It will help you to measure force. Newton's second law will help you to measure the force. How you can measure the force? You need an equation. If you want to measure a force, you need an equation. How we can find an equation? Derive it. From the statement, derive it. What is that statement? What is the statement? We are going to see the expression for force. Expression for force. What is the statement of second law? Rate of change of momentum of a body is directly proportional to external force, right? So the external force is directly proportional to rate of change of momentum. Rate of change of momentum. Delta P by delta. That's the rate of change of momentum. You got it? And you know what is delta P? What is delta P? Delta P is final momentum minus initial momentum. You know that, right? Final momentum minus initial momentum. And that momentum change is taking place in a time delta T. That momentum change is taking place in a time delta T. That's why we can write it like this. F is directly proportional to delta P by delta T. Is that okay? Now, F, you can remove this proportionality sign and you can give an equal to sign. What should you add what should you add if you are changing this relation into an equation, what do you have to do there? You have to multiply with a constant there. You have to multiply a constant there. What is the constant you are multiplying there? Yeah, you can take it as k. You are multiplying that term with a k. So k delta P by delta T. K delta P by delta T. This is now an equation. K delta P by delta T. This is now an equation. You can apply limit to this equation. You can apply limit to this equation. How you can apply limit to this equation? Yeah, applying limit. Applying limit. Applying limit. Limit delta T tends to 0 to this equation delta P by delta T. To this equation delta P by delta T. To the equation delta P by delta T. What will happen to delta P by delta T if you are applying delta T tends to 0? You are applying a limit to the delta T tends to 0. What will happen to this equation delta P by delta T? This will become differentiation. This will become differentiation. And you can write this term like this dP by dt. You can write this term like this dP by dt. Now what is dP by dt? F is equal to k into dP by dt. There is only P now, no delta P, delta T, everything is gone. Now we have differentiation of P. This is what? This is the rate of change of momentum. dP by dt is rate of change of momentum. Change in momentum in unit of time. That's delta P by delta T. Okay? Delta P by delta T. Now what is P? Momentum. What is P? Mass into velocity. Isn't it? Mass into velocity, that's momentum. Mass into velocity. You can write it here. F is equal to K into d by dt of P. What is P? P is mv. P is mv. You can take out m to the other side. Then K into m into, there is only dV by dt. Because m is not changing with the time. M is a constant. M is mass. M is not changing with the time. So you can take out m. If you are taking out m, there will only be b. B is changing with the time. We can change with the time. So that's v dv by dt. Now what is dv by dt? Tell me what is dv by dt. What is dv by dt? Rate of change of velocity. What is that? dv by dt. Answer me. What is dv by dt? Rate of change of velocity. That's acceleration. dv by dt is acceleration. d minus u by t. That's dv by dt. Huh? Yeah. What is this? dv by dt. dv by dt is acceleration. dv by dt is acceleration. You have dv by dt is acceleration. So f is equal to kma. You can write it like that. F is equal to k the m is the a. dv by dt is a. Okay, and you can find the value of k if you are giving units. If you are giving units for the m, for mass, if you are giving unit of kilogram, for acceleration you are giving the unit of meter per second square, you will get the value of k. Value of k is 1. K is 1. Value of k is 1. Then what is this equation? Equation is equal to f is equal to ma. Now this is the equation. This is the equation for force. It is the most important equation in this chapter.
Derivation.
Yeah, you have to study this derivation. This derivation can be asked. This is a simple derivation. Did they teach you this derivation in school?
Yes, sir.
Yeah. Did they teach you this derivation or some derivation like this? Did they teach you this one? Starting from this, F proportional to
Yes,
F
sir.
d by d.
Yes, sir, he did.
Which derivation did you study? This one, which I shown you in the board, or that one? First one or second one?
The first one.
First one. Then you can write the first one. I'll show you the second one. Second one is actually pretty simple without the differentiation. This is actually F is directly proportional. You can take out m. So m into b minus u by t. What is b minus u by t? Yeah, that's ma. And f is equal to kma. K is equal to 1. This is rate of change of momentum, and you can get into that equation very simply. But most of the schools may be teaching this one. This one. That's why I shown you this. If in school, if they are teaching you the other equation, the other derivation, you can study that equation. That will be very simple. I'll write both of the derivations. You can select which is taught you from the school. Okay? Right. Right. Newton's linear momentum. You can start with the linear momentum. You can start with the linear momentum. Linear momentum. You can start with the linear momentum. Linear momentum. In bracket, capital P. Linear momentum in bracket, capital P. P is a vector. Right? Property of a moving body. Property of a moving body. That's momentum. Property of a moving body. That is momentum. Property of a moving body. It is the product of mass and velocity. 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 Then write this equation. P is equal to mv. Write this equation. P is equal to mv. P is equal to mv. After that, you can write the unit. You can write the unit. Unit is equal to kilogram meter per second. Unit is kilogram meter per second. What will be the dimensional formula for momentum? What will be the dimensional formula for momentum? Kilogram meter per second. Yeah, kilogram is mass m, meter L, per second t minus 1. Simply mlt minus 1. That will be the dimensional formula for momentum. Okay. Okay. Then It is a vector. It is a vector quantity. You can write it is a vector quantity. It is a vector quantity. That's a point about the momentum. It is a vector quantity. It is a vector quantity. Then the next point. Both momentum and change in momentum. Both momentum and change in momentum. Both momentum and change in momentum have same direction. Both momentum and change in momentum have same direction. Both momentum and change in momentum have same direction. Both momentum and change in momentum have same direction. Got it? Okay, then you can write change in momentum. Change in momentum. You can draw that figure to understand it better. Change in momentum. Change in momentum. There was a body with a mass m, with the momentum mu, with the initial momentum mu, and a force is acting on it in time delta t. The momentum of the body has changed, that is now mv. Then change in momentum delta p is equal to pf minus pi. Very simple. Simple to understand. You can write what is on the board. Delta p is equal to mv minus mv. Delta p is equal to mv minus mv. Delta p is equal to mv minus mv. That's rate of change of momentum. Now the next point, rate of change of momentum is equal to mv minus mu by delta t. mv minus mu by delta t. That will be delta p by delta t. That will be delta p by delta t. Delta p by delta t. It will be delta p by delta t. That will be enough. Delta p by delta t. That's rate of change of momentum. Rate of change of momentum. Delta p by delta t. Once you have completed it, tell me. Delta p by delta t. You sure? Jaden, Sana, Shiga, did you complete it? What is on the board?
Yes.
Okay. Jaden too.
Yes, sir.
Okay. Further? Can I move? Then you can write Newton's second law of motion. Newton's second law of motion. That's our next point. Next subheading. Newton's second law of motion. Or you can give the number 2. Newton's second law of motion. Newton's second law of motion. You just need to study this, and you can convert this into words. That will be Newton's second law. What is Newton's second law? Rate of change of momentum of a body is directly proportional to external force, and it takes place in the direction. You can write rate of change of momentum of a body is rate of change of momentum of a body is rate of change of momentum of a body is directly proportional to external force. Directly proportional to external force. Directly proportional to external force. Comma. And takes place in the direction of force. 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 Takes place in the direction of force. Got it? You can write this one, this relation. F is directly proportional to delta P by delta T. This relation. F is directly proportional to delta P by delta T. Did you understand this one? Force is, external force is directly proportional to rate of change of momentum. Is that okay? Then expression for force. We are going to see expression for force. Expression for force. Expression for force. Write expression for force. By Newton's second law. By Newton's second law. You can write it like this. By Newton's second law, F is directly proportional to delta P by delta T. F is equal to K into delta P by delta T. K is a constant. You know K is a constant. Now you are applying limit. Applying limit to delta T tends to 0, delta P by delta T will be equal to dP by dt. That will be equal to dP by dt. If you are applying limit to delta T tends to 0 to delta P by delta T equation, you will get dP by dt. So the equation can simply written like this: F is equal to K dP by dt. Or you can skip this whole writing. You can skip the whole writing and simply write K delta P by delta T into K dP by dt. Yeah? When you are getting dP by dt, when you are applying limit, you can skip that idea and you can write it like this: K dP by dt. K dP by dt. What is P? P is equal to mv. So K d by dt of mv. K d by dt of mv. And m is mass. It has no relation with the time. Mass has no relation with the time. Does mass is related to time? Mass is changing with the time, no? Mass cannot change with the time. Okay? So mass can be taken out of the differentiation. That will be Km dV by dt. And we know what is dV by dt. dV by dt is acceleration. dV by dt is acceleration. A. Then the equation will be F is equal to Kma. If you are giving the proper units for M and A, you will get the value of K. K is 1. You can simply take K is 1. F is equal to M. F is equal to M. That's our
You have to prove that K is
equation.
equal to-
No. That will not be asked. Just you can take K is equal to 1. That's not important. What will be the unit of force? What will be the unit of force from that equation? Give me the unit of force from that equation. What is the unit of force from the equation? M, that's mass. M, mass, kilogram. A, acceleration, meter per second square. Meter per second square. The unit of force is kilogram meter per second square. Very simple one, right? And we are taking this unit as Newton. We are taking this unit as Newton with the symbol capital N. With the symbol capital N. Capital N is the symbol for unit. Okay, and you know the dimensional formula also. What is the dimensional formula for force? What is the dimensional formula for force? ml t minus 2, ml t raised to minus 2, ml t raised to minus 2 is the dimensional formula for force. You know that, right? You know that. Okay. What will be 1 Newton? 1 Newton. Can you define 1 Newton? What will be 1 Newton? What will be 1 Newton? When you will get 1 Newton here? When you will get 1 Newton on the left hand side? When mass is equal to 1 unit. When mass is equal to 1 kilogram and the acceleration is equal to 1 meter per second square. So 1 Newton is what? 1 Newton is equal to 1 kilogram meter per second square. So what is 1 Newton? The force needed to give an acceleration of 1 meter per second square to a unit mass. That's 1 Newton. What is 1 Newton? The force needed to give an acceleration of 1 meter per second square to a unit mass. Unit mass is 1 kilogram. You can write it. You can write it. The definition of 1 Newton. This is the definition of 1 Newton. 1 Newton is equal to 1 Newton is equal to 1 kilogram into 1 meter per second square. That will be 1 Newton is equal to 1 kilogram meter per second square. And you can write the definition for 1 Newton or unit force. What is unit force? Write it below it. You can write unit force. What is unit force? Unit force. What is it? Unit force. You can write it. Unit force. The force which produces unit acceleration. The force which produces unit acceleration means 1 meter per second square. the force which produces unit acceleration in a body of unit mass. In a body of unit mass. The force which produces unit acceleration in a body of unit mass. In a body of unit mass. In a body of unit mass. That's our discussion of Newton's second law. We have completed Newton's second law. Then we have only Newton's third law left. After Newton's third law, we will be discussing law of conservation of momentum. It's related to Newton's third law. Then there is a term impulse. Then we will complete one section of the chapter. Then there is only the second section. We just need one more class to complete that section, first section of the chapter. For the second section, we may need some more time. That will be a little bit difficult for you to understand. There comes the vector calculations and derivation. And that will make it a little difficult to understand. So okay, no problem. We will study that. Okay? What is your mood? Can we continue? I just asked that question in the group and no one messaged me. No one informed me what is your mood. What do you think? Do you have any subjects after this? What should we do? Should we continue or we can do that in another session? No, they will be okay because they are in order. My proposal is if I arrange an extra session, can you come? An extra session before we are going to vacations. Before going to vacations or this month. Next week you will be going home.
Next week, I will be there. Next week. End of the next week, I will go.
Okay. What about you? 30th. I will go to India in 26. 26. What about you? July 2nd. So if I arrange an extra session, you all can attend. Maybe.
Which day? What day?
I haven't decided that. I will inform you in the group. So,
26 is Wednesday.
uh,
So when is that?
I don't know. There is class, I will take it, no problem. And we have one more session. One more session, right? We have one more session in this week. Saturday. We will do that on Saturday. We will do the rest of the chapter in Saturday. Okay?
1 hour now there.
Huh?
Extra 1.
Maybe I will inform you. Maybe I will take 1 hour after the session or before the session. After the regular or before the regular, because you will not be having classes in Saturday, right?
Maybe this time it will be like 20.
So sir,
Yeah.
Which school class?
no,
Class.
Ashita?
today is about.
Oh, okay. Okay. Then can I take the class now? Okay.
And
Up to 7:30 you are okay. Up to 7 o'clock you are okay. Up to what time are you okay? Guys, Jaden, Sana, Shiga, can I continue the session up to 7?
Yes, sir.
Yes, sir.
Okay, that will get us more time. If we have that much time, we can almost complete one session. 7. Up to 7. Up to 7. Is that okay?
Yes, sir.
Yes, sir.
Thank you. Here, we are going to discuss about mass and weight. This will always confuse you if you hadn't understood that until now. Mass and weight. What is this mass and weight? If you are selecting a body, if you consider a body, that body is made up of matter, right? That body is made up of matter. That means the amount of matter present in that body can be called its mass. Can be called its mass. The amount of matter present in that body is called mass. And that mass is represented in kilogram. What is the unit of mass? Represented in kilogram. With what device you can measure this mass? It's a fundamental quantity, you know that. It's a fundamental quantity. With what device you can measure mass? With common balance. With a device called the common balance. With a device called the common balance, you can measure this quantity called the mass. What about this weight? Weight is actually the gravitational force acting on this object. There will be gravitational force acting on every object in the universe. Every object in the universe, if that is nearby to any other object, which is having mass, there will be gravitational force of gravity between them. Okay? If we are talking about the cases in Earth, what happens there? What we can say about the gravitational force of Earth? Earth is exerting that gravitational force to every object that is in the gravitational field of Earth. Okay, so if you have an object like this and that object has a mass m, then there will be a gravitational force on that object. That gravitational force, you can take that gravitational force as Fg. Fg is what? The gravitational force. Fg, gravitational force. Okay, and that gravitational force will become weight of the body. That gravitational force will become the weight of the body. So what is weight actually? Weight is the gravitational force acting on that body. Weight is the gravitational force acting on that body. That is weight. Okay, and the weight will have an equation like this, mg. Mg is the equation of weight. This is the equation of weight. W is equal to mg is the equation of weight. Did you understand the difference between mass and weight? Mass and weight. What will be the unit of weight? Yes, unit of weight is very simple because weight is itself a force. Weight is a force. So what will be the unit of weight? Unit of weight will be unit of force. What is unit of force? Newton. So unit of weight will be Newton. Unit of weight will be Newton. Yeah? No. That's actually we are referring to mass, not weight.
No, we stand on the measure weight. Area.
Yeah, that's actually the practical unit of mass. Sorry, practical unit of weight. I will tell you that. Practical unit of weight.
So that's not good.
No. Practical unit of weight. Practical unit of weight is kilogram weight. You know, kilogram weight. If there is an object and that object has 50 kilogram mass, you can take or you can say it has 50 kilogram weight. That's kgW. Yes, 50 kilogram weight. But what will be the actual weight of that if you are stating in Newton? Yeah, no, that's not 50 Newton. That's 50 into G. What is G? G is 9.8. Or if you are taking that, rounding that into 10, that will be 500 Newton. 500 Newton will be the weight of that object. This will give you an idea how much does it weigh.
So that's mass.
Yes. If you are specifying that in kilogram, that is mass.
So if we take a weight and go to the other side of the
Yes, it will change.
So mass cannot change.
Mass cannot change.
Relative as mass.
No, you will be getting weight there. You are not measuring mass with an electronic balance. If this is an electronic balance, you are not taking the weight of the body. You are taking, sorry, you are not taking the mass of the body, you will be taking the weight.
This 100 meters.
Yeah,
It's showing 50 kg.
yeah. This is actually what practical unit of weight. It's not 50 kg. It's not 50 kg, it's 50 kilogram weight. You will understand how much does it weigh. How much it will weigh. Did you understand that? How much does it will weigh? We will understand that idea. But if you need that in proper units, that will be in Newton. If you need that in Newton, that's not 50 Newton. That will be 50 into 10 Newton. 500 Newton. That is the proper unit of it. That is the proper unit of weight. Got it? Proper unit of weight. Okay? So that's the idea. If you need the mass, if you need the correct mass, what do you have to do? Yeah, you have to take the common balance measurement. If you are taking the common balance measurement, you will get the correct mass of it. Most of the times we will be referring to weight. Okay? Most of the times we will be using the weight, the idea of weight. That's why it will be confusing for us, mass and weight. Mass is stated in kilogram, weight is stated in Newton, but sometimes we will say 50 kilogram. 50 kilogram, what does it mean? It does not mean the weight is 50 kilogram. It means the weight is actually 50 kilogram into 9.8 Newton. Or 50 kilogram weight. 50 kilogram weight means 1 kilogram weight. I will write 1 kilogram weight here. What is 1 kilogram weight? 1 kilogram weight is 9.8 Newton. 1 kilogram weight is 9.8 Newton. Got it? 1 kilogram weight is 9.8 Newton. If I am saying this object has 50 kilogram weight, what does it mean? It has mass of 50 kilogram and the weight of the object will be 50 into 9.8. That will be 500 Newton. Got it? This is it. You can write it. The difference between mass and weight. Difference between mass and weight. Draw a column and you can write the difference between mass and weight. Below mass, you can write. Below mass, please write. Amount of matter contained in a body. 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 Okay, amount of matter contained in a body. And unit, you can write the unit. You can write the unit. What is unit? Kilogram. 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 It is a scalar quantity. It is a scalar quantity. Kilogram. It's a scalar quantity. It's a scalar quantity. Okay. Below weight, you can write. Below what weight, you can write. You can draw this figure below weight. Draw the figure below weight. M is the mass of the body and Fg is the gravitational force, and that gravitational force is actually weight. You will understand it better if you are drawing this figure. If you draw this figure, that will make you understand the concept more easy. Okay. Got it? Then you can write, it is the force with which, it is the force with which the body is attracted towards the earth. The force with which the body is attracted towards the earth. The force with which the body is attracted towards the earth. The body is attracted towards the earth. W is equal to mg. W is equal to mg. That is the equation for weight. W is equal to mg. That is the equation for weight. W is equal to mg, and you can write the unit also. Unit Newton. Unit Newton. It's a vector quantity. It's a force, so it's a vector quantity. It is a force, so it's a vector quantity. Vector quantity. Next point. Weight of the body changes from place to place. Weight of the body changes from place to place. Weight of the body changes from place to place. Weight of the body changes from place to place. Weight of the body changes from place to place. Got it? Then you can write in SI, in SI unit, in SI unit, in SI unit, practical unit of weight will be practical unit of weight is kilogram weight. Practical unit of weight is kilogram weight. Kilogram weight. In bracket, weight of 1 kilogram mass. 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 Okay? Weight of 1 kilogram mass. And you can write this. 1 kilogram weight is equal to 98 Newton. 1 kilogram weight is equal to 98 Newton. 1 kilogram weight is equal to 98 Newton. Write this. 1 kilogram weight is equal to 9.8 Newton. 1 kilogram weight is equal to 9.8 Newton. 1 kilogram weight is equal to 9.8 Newton. Then you can also write this 50 kilogram. What does it mean? 50 kilogram is 50 kilogram weight. That will be 50 into 9.8. You can simply take it as 10, approximate it to 10. Then that will be 500 Newton. 500 Newton. Okay. Okay. Then we have to write some points about this second law. We have to write some points about the second law. That's very simple. Can I move to the next page? Can I move to the next page, everyone? The points about the second law, they are very simple. If force is 0, that means acceleration is also 0. Right? So write it now. I will give you the note. If force is 0, what does it mean? Acceleration is equal to 0. And the second one is actually a vector law. It is a vector law. It is a vector law. What is a vector law? What is a vector law? Yeah, vector law means it is like this actually. F is equal to mass into acceleration. This is a vector law. That means the force will have different components along x-axis, along y-axis, along z-axis. So the component of force along x-axis will be what? That will be mass into component of acceleration along x-axis. Right? What will be component of force along y-axis? Component of force along y-axis will be mass into component of acceleration along y-axis. What will be component of force along z-axis? That will be mass into component of acceleration along z axis. Because this is a vector law, we can write it like this. This is the vector law and we can write it like this. Okay? And if there is a system of particles, if there is a system of particles, more than one particles, if there is a system of particles, for a system of particles, if there is more than one particles, multiple particles, and force is equal to what? Force is equal to mass into acceleration. What will be that? This is the external force that is applied to the system. That will be mass into acceleration. Which is this mass? Mass is the total mass. That's the total mass. What will be the acceleration here? Acceleration here will be the center of mass. Acceleration of the center of mass. Center of mass is a concept that we will study later. Center of mass is actually the point where all mass is concentrated. There will be a point for a body where the whole mass is concentrated. That point is called center of mass. So this is F is equal to ma means force is equal to mass, total mass into A. A is acceleration of the center of mass. Right? So it will be like this. If you have two bodies like this, the center of mass of the body will be in between them. Center of mass of the body will be in a point that is connecting centers of both of them. That will be the center of mass of the body. So we will be looking at this point for acceleration. If we are applying a force here, and the mass will be m1, m2. The total mass will be m. Total mass will be m1 plus m2. That will be the total mass. And total mass into acceleration of the center of gravity will give you the total force of total force that is acting on that system of particles. Okay, we will study more about the system of particles later. Now, the fourth point. Once you have stopped applying the force, it will not have any memory of the force. The body will not have any memory of the previously given force. Once the force is removed, it will be completely off the hook of force. There will not be any influence of the previous history of force. If you are applying a force to this object, and you are removing the force, it will look like there was no force before. Right? It is like this. If a body is moving, if a car is moving, and I am sitting in the car, and I have a ball, I'm throwing that ball vertically upwards. Where does the ball will reach? Where does the ball will fall? Ball will move up and down. It will fall into my hand, right? It will fall into my hand if I am sitting on a moving car. But for Joshua is out of the car and he is just observing me. And for him, me, the car, the ball, everything is moving. So if I am throwing the ball up, Joshua is just seeing. For Joshua, the path of the ball will be like this. For Joshua, the path of the ball will be like this. But for me, the path of the ball will be like this. Did you understand that? For me, the path of the ball will be like this. If I am throwing it up, it is moving up and it is falling into my hands. I have that vertical motion. For me, it's a vertical motion. For Joshua, who is outside of the car and observing me, the motion of the ball will be like this. For him, the ball is moving forward. Because the horizontal velocity of the ball is a constant. The ball will have a horizontal velocity. Got it? Okay. You can write the points. F is equal to 0, A is equal to 0. F is equal to 0, A is equal to 0. If force is 0, there is no acceleration. And it is consistent with the first law. This is actually the first law itself, right? This is actually the first law itself. Right, guys? This is actually the first law. If there is no force, there is no acceleration. The body will be moving in uniform motion. No acceleration means the body is moving in uniform motion, uniform velocity, right? Second one. It is a vector law. It is a vector law. So fx is equal to max, fy is equal to may, fz is equal to maz. Okay. Third one. For a system of particles, F is equal to ma. F is equal to total F is total external force. A is the acceleration of center of mass. Acceleration of center of mass. A is acceleration of center of mass. Center of mass means there will be a point to every body where the whole mass is concentrated. For a sphere, that will be the center of mass.
For us, it will be a length.
Huh?
For us, it will be.
Yeah, for us, it will be somewhere here. Somewhere here. Huh? If we are standing like this, our center of mass will be about here. Center of mass will not be changing. Yeah, it's constant. Center of gravity can be changed. Center of gravity is another thing.
Center of gravity will be a length.
No, center of gravity is the point where the whole weight is concentrated. Sometimes it will be on the same point. For a sphere, it is on the same point. For center of mass and center of gravity will be on the same point. We will study about that in next chapter.
There.
Yeah, we have to study that in the next. Okay, F is total external force, A is acceleration of center of mass. Right? Then, fourth one. Acceleration at an instant is determined by. Acceleration at an instant is determined by. Acceleration at an instant is determined by. Velocity at that instant. Sorry, force at that instant. Acceleration at an instant is determined by force at that instant. Force at that instant. Acceleration at an instant is determined by force at that instant. Got it? Can we talk about impulse? We have no, we don't have that much time. Just 2 minutes. Don't have that much time to discuss about impulse. We will do that in the next session. Okay? See you. Thank you for being here. Guys, we will continue the discussion in the next class, next session.
Okay, sir.
Saturday.
Yes, sir.
See you all.
Bye.
Thank you, sir.
Thank you, sir.
Thank you.